Most people look at the pyramid and see perfection, but hidden inside that stone giant are silent reinforcements that may have stopped total collapse. And once you get close, the first strange clue appears. These blocks are carrying impossible weight, yet the structure has endured for thousands. See those fractures? They look like weakness, but some researchers believe damage like this reveals how the pyramid distributed pressure instead of simply breaking apart. Then inside, everything changes. Tight passages, angled ceilings, and massive stone layers start feeling less like decoration and more like survival engineering. Ancient carvings may not explain everything directly, but they suggest something important. These builders understood weight, balance, and stone behavior far better than expected. So, the real question is not whether the pyramid was strong. The real question is whether hidden reinforcements were planned from the beginning. Because above the king's chamber sits one of the biggest clues of all: stacked relieving spaces designed to redirect crushing pressure overhead. Those giant granite beams were not placed there for beauty. They were there because somebody knew this chamber needed protection from enormous weight. Now imagine all that pressure traveling downward for centuries. Without smart reinforcement, cracks spread, chambers fail, and the pyramid slowly destroys itself. And that is where this story gets fascinating, because the pyramid may not just be ancient stone, it may be ancient structural genius. At first glance, the pyramid looks simple, but that shape might be the first secret protecting it from collapse under millions of tons. Each block locks into the next, distributing pressure across the structure, so weight spreads outward instead of crushing the pyramid from above. Inside the pyramid, the stone arrangement becomes more complicated because the internal structure isn't just stacked blocks, it's a carefully layered system. Even during construction, the builders seemed to understand how every layer had to support the next without creating dangerous pressure points. Look closely at some passages and you'll notice the ceilings aren't flat. They're angled to redirect weight away from vulnerable spaces. Engineers today believe this design forces pressure to travel outward toward the pyramid base instead of concentrating directly above its chambers. And when all that weight finally reaches the base, the pyramid spreads it across an enormous footprint anchored deep into the desert bedrock. Ancient drawings may not explain the physics, but they hint that Egyptian builders carefully planned the structure long before the first stone moved. And those massive granite slabs above the king's chamber might be the most important reinforcement system inside the entire pyramid. But the deeper scientists look inside the pyramid, the more they realize its structural protection system might be far more complex. Deep inside the pyramid sits the king's chamber, a room surrounded by millions of tons of stone pressing down from above. At first glance, those granite ceiling slabs look strong enough, but they're actually carrying more weight than almost any room on Earth. Above that chamber sits the entire pyramid core, creating unimaginable pressure that should crush a flat stone ceiling over time. But directly above the chamber, ancient builders created a hidden empty space designed to absorb and redirect the crushing pressure. And that space wasn't alone, because there are actually 5 separate relieving chambers stacked above the king's chamber ceiling. Each chamber works like a pressure buffer, preventing the enormous stone mass above from pressing directly onto the chamber below. Instead of crushing the ceiling, the pressure travels sideways through the beams and surrounding stone structure. Those granite beams weigh several tons each, meaning the builders intentionally installed enormous structural elements to manage pressure, which raises an incredible possibility. The pyramid builders understood structural engineering principles thousands of years before modern science. And yet, the relieving chambers might only be one piece of a much larger reinforcement system hidden inside the pyramid.
One of the most unusual spaces inside the pyramid is the Grand Gallery, a towering corridor that looks less like decoration and more like engineering. Instead of using a flat ceiling, builders stacked stones in overlapping layers that gradually move inward. That angled structure pushes the enormous weight outward into the pyramid walls rather than directly downward onto the corridor below. Even the pyramid's corridors follow precise angles, suggesting the entire internal layout was designed with structural stability in mind. These corridors are not randomly placed. They form a carefully arranged network that may help distribute stress throughout the pyramid's core. Another chamber sits lower in the pyramid, placed in a position that may help balance internal structural pressure. The positioning of these chambers might act like structural relief points, allowing pressure to spread through the pyramid instead of building in one location. Instead of concentrating stress in one area, the pyramid redirects force through its massive stone layers like a giant pressure control system. From the outside, the pyramid looks simple, but inside it may contain one of the oldest structural engineering systems ever built. And if that is true, then the pyramid was never just a tomb, it was a masterpiece designed to survive thousands of years. Today, the pyramid looks rough and stepped, but originally it was covered in smooth limestone casing that protected the structure beneath. Those casing stones created a protective outer shell that helped distribute pressure and shield the inner stone core from weather and erosion. Over centuries, many of those stones were removed and reused in buildings across Cairo, leaving the pyramid's structural core exposed. Once the protective casing disappeared, the inner stone layers began facing wind, sand, temperature changes, and centuries of erosion. Earthquakes have also struck Egypt over the centuries, sending shock waves through the pyramid's enormous stone structure. Those tremors may have created small fractures inside the pyramid, revealing just how much pressure the structure constantly carries. Yet instead of collapsing, the pyramid seems to absorb and redirect those forces through its massive stone layers. Even desert storms slowly grind the surface of the pyramid, wearing away limestone after thousands of years. The pyramid we see today carries scars from history, yet somehow the core structure remains stable, which suggests something remarkable. The ancient builders may have designed the pyramid to survive damage long after they were gone. Today, scientists are studying the pyramid with advanced technology, trying to understand how a structure this massive could survive for thousands of years. Engineers now use computer simulations to test how the pyramid distributes weight through millions of tons of stone. These simulations show something remarkable. The pyramid shape naturally pushes pressure outward rather than directly downward through the center. The geometry itself plays a major role because the triangular design spreads structural stress across the entire monument. Instead of crushing the center chambers, the pyramid forces that pressure toward its enormous base anchored directly into the bedrock of the Giza Plateau, which means the builders probably understood ground stability long before the first stone block was ever placed. In some ways, the pyramid behaves like modern structural designs used in large buildings today. That means many pyramid features once thought symbolic might actually serve important structural roles. And the more researchers study the pyramid, the more they realize its builders may have mastered structural design thousands of years ago. Even after centuries of research, the Great Pyramid still raises a strange question. Did its builders secretly include structural fail-safes inside the monument? Because when scientists map the pyramid's interior, they sometimes discover empty spaces that don't appear connected to the main chamber system. One modern scanning experiment even revealed a huge hidden void above the Grand Gallery that had remained completely unknown for thousands of years. Researchers still debate what that space actually does, because it might serve a structural purpose rather than simply being an empty chamber. In some engineering designs, empty cavities act like pressure buffers, allowing massive structures to absorb stress without cracking or collapsing.
Which raises an astonishing possibility. The pyramid builders may have intentionally placed hidden spaces to protect the structure from future stress. Those cavities might even help absorb vibrations during earthquakes, preventing cracks from spreading through the pyramid's enormous stone core. And the deeper archaeologists explore the pyramid, the more they suspect there may still be unknown spaces hidden inside. If that is true, the pyramid may contain structural reinforcements we still haven't discovered. And that possibility means the pyramid could still be hiding engineering secrets waiting to be discovered. One of the best clues about pyramid engineering is actually visible on the stones themselves. Many blocks fit together so tightly that even today it's difficult to slide a blade between them. Some stones even show compression marks created by thousands of years of weight pressing downward. Those pressure marks reveal something remarkable. The stones are carrying enormous loads, but the structure remains stable. The internal stone layers also show a staggered arrangement that spreads weight across multiple blocks instead of concentrating pressure in one place. Even the surfaces inside the pyramid reveal how the structure has slowly shifted and settled over time without collapsing. Modern engineers studying those patterns see clear evidence that the pyramid distributes pressure through its stone layers. The angled ceilings and corbel structures also show exactly how weight moves through the building. All these clues together tell a powerful story about the builder's understanding of stone and structural balance. And those clues suggest the pyramid may have been engineered far more carefully than most people imagine. After thousands of years of pressure, earthquakes, and erosion, the Great Pyramid still stands almost exactly where its builders placed it. And the reason becomes clear when you look at the entire internal system working together. The pyramid shape spreads weight outward instead of forcing it downward through the center. Above the king's chamber, massive granite beams redirect pressure away from the ceiling. The grand gallery's angled walls push structural stress toward the outer pyramid walls. The base of the pyramid spreads that weight across a massive foundation resting directly on bedrock. Even earthquakes struggle to damage the structure because the internal systems redirect stress throughout the pyramid. Hidden spaces inside the pyramid may also act as pressure buffers, absorbing structural stress. When all these features combine, they create one of the most stable structures ever built, which explains why this ancient monument continues standing thousands of years after its builders disappeared. After thousands of years, the Great Pyramid still rises above the desert almost exactly as its builders intended. Standing beside it today, it's hard to believe this monument was built using ancient tools and human labor. Yet somehow, these builders created one of the most structurally stable monuments ever constructed. Their understanding of balance, weight, and stone placement may have been far more advanced than we once believed. Inside the pyramid, every chamber, corridor, and stone layer works together like parts of a massive engineering system. Empires have risen and fallen, cities have grown and vanished, yet the pyramid continues to stand. Under the night sky, the pyramid feels less like a ruin and more like a silent monument to ancient knowledge. Together, the pyramids remind us that ancient civilizations were capable of extraordinary achievements, and hidden within those stones may be one of the greatest structural designs ever created, which means the Great Pyramid may not just be an ancient tomb, but a masterpiece of engineering built to survive eternity. If you enjoy real history that feels unreal, subscribe and like the video so you don't miss the next story. Thank you.